Okay, this is lesson 72, number 20. I think I'll fold this over so we can see better. Number 20 says, solve the following equations. So x has to be greater than 0. Oh, t and x both have to be greater than or equal to 0. Wait, what? Theta, what? Theta has to be less than 2 pi. So basically I don't have to go around and around and around the unit circle, I guess is what that's saying. Sine squared, so let's do this thing. Sine squared x cosine x equals cosine x. Okay, so what we like to do, even though it's tempting, you might just want to divide both sides by cosine x, you will lose some solution, you'll lose at least one solution by doing that. So what you want to do is do some factoring and use a zero product property. So if you bring everything over to the left hand side and set it equal to 0, then you can factor and do the zero product property. So I see that I can factor out cosine x, of course, and then I can get sine squared x minus 1 equals 0. Well, that's actually a difference of squares, because I can rewrite that as sine x plus 1 and sine x minus 1. Okay, and then I can use the zero product property. So that says cosine x equals 0, sine x plus 1 equals 0. So I'm just going to say sine x equals negative 1 equals positive 1. So three things can happen here because we have the 1, 2, 3 factors. So I set them each equal to 0 and solved them. Well, I haven't really solved them though, because to solve them you have to inverse, you know, sine or inverse cosine. So basically you need the angles where cosine x is 0. So I'm addicted to this unit circle, so I think I'll probably just grab my unit circle. Where is cosine x is 0, and then we have at the beginning of the problem that x is going to be greater than or equal to 0. Okay, so where's cosine x is 0? Cosine is, I guess it's at 90 degrees and at 270 degrees. Are we in degrees here? Radians? How do we know we're in radians? Oh, because of that? Okay. Okay, oh, the angle's less than 2 pi. Okay, I guess I was having trouble understanding this notation. And then I guess the t's just there because this problem has t's in it, huh? Okay, I guess that makes sense. Okay, so we're in radians, so we're going to say pi over 2 and 3 pi over 2 for this one. And then where is sine x negative 1? Well, that's the only place, huh? Just 3 pi over 2. Oh, we already got that, huh? And then where's sine x positive 1? I guess that's only going to happen at pi over 2. So I guess we just got 2 answers. Yeah, no?
I think it's just pi for sine x equals 1.
Oh, for sine x equals 1?
Yeah. No.
Sine x equals 1? Yeah.
My answer is in degrees because it says x is greater than or equal to 0, and there's one at x equals. I didn't know what 0 was.
Yeah. Yeah, the notation's kind of weird. We got, this is the answer.
Okay.
But the notation was kind of confusing, but I think it's what Seth was saying. I think it's true that the angle, theta is the angle. The angle has to be less than 2 pi.
Which is 360.
Yeah, which is 360. And then x and t are gonna be positive, or greater than 0. But we don't care about t, 'cause t's in the problem net. T's not in the problem net,